This is our last video for 3A. So we are on the back of your chart and the last section at the bottom. What we're going to do is work on graphing the exponential functions that have been transformed. So when we did this, the first thing we did was we started by graphing the parent graph first. And if we do that lightly, maybe even with like a dotted line, then what we're going to do is do the transformations, and that's going to be the end result of that will be the graph of the function. So when I go over here, first thing I need to identify is what the parent graph is, and it's 2 to the x. So if you're not sure of what the graph of 2 to the x looks like, then what we can do is make a quick t-table to refresh your memory. So 2 squared would be 4, 2 to the first would be 2, 2 to the 0 is 1, 2 to the negative first is 1/2, and 2 to the negative second is 1/4. So the graph of 2 to the x, 0, 1, 1, 2, 2, 4, and then these are getting closer. So this is the graph of 2 to the x, right there. So I'm just going to do that pretty lightly in pencil. Here, let's zoom in a little bit more for you so you can see it. All right, so now looking at the transformations, this +1 tells me that I need to shift this graph left 1, and then the +3 on the end tells me that I need to shift the graph up 3. So what I'm going to do is I'm going to take these original points, and this one I'm going to do in pen. Here's a point right here. I need to go left 1 and up 3, and that's the new point. I'm going to take this point. I'm going to go left 1 and up 3, and it belongs right there. Take this point, left 1, up 3, it belongs there. Take this one, go left 1, up 3, it's going to go in there. This one, which is down at a 4th, I'm going to go left 1 and up 3, so it's going to be right there. So the transformed graph is right there. All right, for the number 15, what we're going to do on this one is same thing, except this one starts with the parent graph of 3 to the x. So again, I don't know if you remember what 3 to the x looks like. We actually have the parent graph of 3 to the x from number 8 above. So I'm not going to make a t-table, but at 0 it's 1, at 1 it's 3, at 2 it's 9, so 3, 6, 9 is right there. And then this is at a 3rd and then at a 9th. So this is the parent graph of 3 to the x. So the parent graph is 3 to the x. That's your parent graph. All right, now this 1/2 tells us that we need to shrink this graph to be half of its height. And then the +2 tells me that we need to go left 2. So what we're going to do is shrink this to be half of its height and then go left 2. So instead of going up to 9, I'm going to go up to 4.5, but then I need to go left 2 and put a point. On this one, instead of going to 3, I need to go to half of its height, which would be 1.5, and then left 2. All right, this one is at 1, so I need to go to half of that height, which is 1/2, and then go left 2. This one is at a 3rd, so I need to go to half of that height and then go left 2, but we know it's just going to get closer and closer to 0. So this one looks like that. So it's not quite as tall, not as stretched out, and it's been shifted 2 spaces to the left. So whenever you're graphing a transformed function, you want to start with the parent graph, graph that one first, and then use what you know about how these numbers affect your graph to make those changes right there on the graph, and then connect your points.